Hello, this is Module 7 of Mathematics course. We have looked at various concepts previously. So, in this module, we are considering logic. We'll look at the foundations and the application of logic. When we hear logic, we talk about reasoning. Logic is the branch of mathematics that is concerned with valid reasoning, making valid reasoning and correct inference. It distinguishes true from false statements and shows when conclusions follow necessarily from premises. So, in this module, you will be introduced to symbolic logic. We'll look at propositions, logical connectives, truth values, conditional statements, biconditional statements, negations, truth tables, argument validity, and even fallacies. So the mastery of this develops precision in reasoning. It will help you to reason properly, and it will help you to apply this concept across mathematics, science, business, technology, agriculture, sports, and even you apply logic in everyday decision making. Now, in this, we are looking at propositions. What are propositions? You can call it proposition or statement. So, in proposition, a proposition is a statement that is either true or false and contains no connectives. That is a proposition, a simple proposition. But we have two types of proposition. We have simple proposition and compound proposition. So a simple proposition is a statement that can be either true or false and contains no connectives. It cannot be broken into sub-proposition. That is why it is simple. But in compound proposition, it is formed by joining two or more simple statements with logical connectives. Logical connectives can be and or if. If you join two statements with or propositions with the word and or if, then, and if and only if. So when you use all those terms, we call them connectives, logical connectives. We say a compound proposition is formed. And this compound proposition can still be broken down into sub-propositions. Like it can be broken down into simple proposition. So logical statements generally are denoted by letters P, Q, R, etc. So questions, commands, exclamation, and emotional expressions are not propositions. Note that questions are not propositions, commands, exclamations, and even emotional expressions are not considered as propositions. So let's look at logical operators and symbols in detail. When you are studying logics, in mathematics, we come across these symbols. For conjunction, you see it P, you see this, all right? So conjunction can be true only when both P and Q are true. But if otherwise, so conjunction can be true only when both P and Q are true. While for disjunction is true when at least one of P or Q is true. But it is false only if both are false. So if you have two statements P and Q, if P is false and the second statement Q is false, that means the statement is a disjunction. So it is false. Okay? But for conditional statement, one is false only when P is true and Q is false. So if one is true and the other is false, one is false. For instance, the P is the antecedent while the Q is the consequent. So if the antecedent is false, okay, the consequent will also be false. So false only when P is true and Q is false. Let's look at biconditional statements. Now, in biconditional statement, it is true when P and Q shares the same truth value or truth table. When both true, either both true or both false. If P and Q are both true or they are both false, we say that it is true. So that is how it is in biconditional statement. Then negation. Negation is simply the reverse of truth values. So if P is true, the negation of P is false, and vice versa. So if I say P, it rained heavily today. If that is P, the negation of P will be it did not rain heavily today, like the opposite or the reverse of the statement. Now look at this. I've talked about connectives. Connectives are words which combine simple statements to form compound statements. So they are called logical connectives. So we use it a lot in mathematics. So, and these are truth tables. Truth tables are used to compare two different statements. Okay, either P and Q or Q to R, as the case may be. So let's look at that truth statement again. Let's go back to it. Look at this example. Use the truth table to show that P is joined with, that is or, that sign there is or, is equal to negation of P is and negation of Q. So look at it. Let's see for disjunction between P and Q. If P is true and Q is true, at the end of the day, what will it be? It will be true, because what is joining is disjunction. It will be true. But if P is true and Q is false, at the end of the day, the statement will be what? Will be true. But if P is false and Q is true, the statement will be true. But if both are false, it will be false. Now observe carefully that if one of them is true, that means it is true. Now the negation of it will be opposite of what is there, all right? So if P is true and Q is true, what is the negation of P? The negation of P will be false. The negation of Q will be false. But in the opposite, like I said, negation refers to the reverse of a statement. That's negation, the reverse of a statement. So you'll be wondering, what do we use this for? Sorry for the break. Let's continue. All right. So let's look at biconditional and chain rule. We call it syllogism. In biconditional, it is true when P tends to Q and Q tends to P. Both will hold, but you can also apply chain rule. If P imply Q and Q imply R, it means that P implies R. So this transitive form yields valid deductive conclusion when premises follow the chain. For instance, if P means student work hard, and Q means passes exam, and R means awarded certificate, so from P imply Q, and Q will imply R. So we can quickly deduce that P implies R. So it means that students work hard, so they were awarded certificates. So that is what it means. So we use it for deduction a lot. So the argument is valid just by chain rule. Now let's talk about deductive reasoning and inductive reasoning. We have to look at that. Very important. The validity of arguments. Deduction versus induction. What is deductive reasoning? Deductive reasoning is actual reasoning that starts from premises and derives conclusions that must be true if the premises are true. So the validity depends on the structure, not the content. But in inductive reasoning, it means drawing generalized conclusions from observations. So it lacks guarantee because not all possibilities are exhausted. So an argument is valid when true premises always yield a true conclusion. So if the conjunction of premises is a tautology with the conclusion, the argument is valid. Otherwise, it may just be a fallacy. Now, looking at all these logic, where do we apply reasoning? Logic simply means it's the science of reasoning. So where do we apply reasoning? You will agree with me that reasoning is applicable to virtually all fields and walks of life, from business to agriculture, to sports, to science, and even to technology. We applied logic a lot. In business, for instance, managers use conditional analysis and Boolean filters for decision trees, targeting A and region B, and consistent strategic planning. All right. In agriculture, rule-based automation. If rainfall is less than threshold, then activate irrigation. In agriculture, logic can also be applied. What about sports? In sports, in the formulation of tactical rules, for instance, if opponent weakens defensively, then increase offense. You see, that is simple logic. It's applicable to sports. In science is based on hypothesis testing. And hypothesis follows deductive logic. So if theory is true, then observation must follow. So logical control isolates variables to avoid faulty inference. So in science, we make a lot of hypotheses. Hypothesis simply means making tentative proposition or intelligent guess about an observation. Then even in technology, digital systems implement Boolean operations, programming conditional and hardware logic gates. All those are possible because of logic. You can see that logic is applicable to every walk of life, including family, marriage, every walk of life. We apply logic. So you can see that logic is very important. So in this module, you have learned that logic equips learners to evaluate statement. Logic will help you to evaluate statement. It will help you to detect inconsistencies and even construct sound arguments and apply rigorous reasoning across different disciplines and walks of life. Thank you for listening.